going to dive into a number of different elements here. Obviously, we'll get into some of the basics of just vertical cuttings dryers, but we'll move into some of the things that have plagued vertical cuttings dryers over the last couple of decades. In fact, it is important to note that Elgin was the first to introduce vertical cuttings dryers into the oil and gas industry in 2002, just 20 years ago, oddly enough. And that was to a company at that time called New Park Resources. They were the first to take the big dive into deployment of vertical cuttings dryers in the oil and gas industry. And a lot has happened in that 20-year period. And so we'll talk a little bit about that and how that has helped, in some cases hurt. But there's a lot to be able to kind of unpack with that. So one of the first things I'm going to do before we kind of get into some of those things is talk about just the general basics of vertical cuttings dryers. And really, I think it's important to note there are two basic configurations. We have the classical fixed speed dryer. This has been the dryer that was introduced to the market, specifically the oil and gas market, back in 2002. Now, of course, it's now operating in a number of additional markets beyond the oil and gas market. In fact, we're utilizing them in everywhere from food and beverage to pipeline construction to dredging. And it's going to continue to find opportunities for additional dryers to the market. But the fixed speed dryers, when it was initially introduced at the time, was actually from the mining industry. The mining industry utilized the classic fixed speed dryer for probably a good 40 to 50 years prior to Elgin's introduction of it, even to the industrial side of the business, what we consider the oil and gas and other markets in 2002. So it's got a long history and it's got a long path that it's kind of taken. But oddly enough, the fundamental technology in the classic fixed speed dryer has not greatly changed over the last, I'd say, 4 or 5 decades. Very similar in regards to a two-stage planetary gearbox, fixed speed output, belt driven, has an oil lubrication system to be able to manage the gears within that planetary gearbox. And it does its job. It's been a workhorse, and it's certainly been a product that we've been proud of for many, many years. And then as things evolved, the market, well, the feedback that came in really was demanding a different type of dryer. And that's where the modern direct drive or direct dual drive dryers kind of came to being. Now, they didn't actually come to market until about 2016 or so. So this is a relatively recent addition to the market when you consider the evolution of the product line. But this is a very different scenario than the classic fixed speed dryer. It utilizes 2 independent motors. Both motors are controlled by a variable frequency drive. Those motors provide you independent differential through a set of gearboxes, whereas the classic fixed speed dryer actually has just one dual stage planetary gearbox. The modern direct drive dryers now have 3 gearboxes, of which, and then the major gearbox is a 3-stage planetary versus 2-stage. It gives us a lot more differential capability, a lot more G-force adjustment, which of course you can't get that with a fixed speed dryer, as well as more torque than its cousin. If you were to look at a classical 4 series dryer compared to the current direct dual drive 4 series, we actually have much more torque and much more operating bandwidth with the modern direct dual drive dryers. Which is quite surprising and something that was more of an artifact of what we discovered based on the gearbox technology and moving that from a 2-stage to a 3-stage. But these fundamentally make up the 2 basic dryers. And when you consider what's been put out in the market to date over the last couple of decades, really most of what's out there is the classic fixed speed dryer. In fact, of the 900 units that Elgin has put out into the market, which we do believe we're probably about half of that market. So we do maintain a fairly large share in the overall scheme of things. The reality is that of those 900, maybe, a tenth of those, maybe a fifth of those. I'm saying, no, not a tenth, probably, yes, actually say 5% of that 900 has been the direct dual drive dryers. So that tells you just how recent that addition is. And if you think about all the things that have been happening within the market since 2016, besides implosion with different markets and COVID-19 and everything else, it certainly had a slower start than was anticipated. But I will say, as of today, the modern direct dual drive dryers are certainly more popular than the classic fixed speed dryers, just simply because of all their flexibility. But without getting bogged down, I want to kind of identify the fact that we're really working with a washing machine designed for rocks and dirt. Everybody asks, and we get a lot of questions about really what are we getting when you're dealing with a vertical cuttings dryer. And just imagine the spin cycle in your washing machine. And that really gives you a pretty good idea of what you're dealing with. And the drum within that washing machine really is the screen that we're looking at within a vertical cuttings dryer. And the G-force is really dictated by the diameter of that screen and how much rotational speed you put in within regards to that overall screen diameter. So the larger the screen diameter and the higher the actual rotational speed, the more G-force that you're going to create out of it. The fact is that of the physics, of the different parameters that are used to govern the performance of a vertical cutting dryer, G-force is the defining feature. However, relative to what you get from that G-force and how well that G-force actually achieves dewatering is actually based on residence time. And residence time is something that comes as a result of the amount of surface area that that screen has and how fast the solids are being pushed through the screen. And the flights have a lot to do with how fast the solids are being pushed through. That's why you see that angled attack with those flights and the ability to scrape away the material off the surface of the screen. However, when you look at the overall residence time and be able to govern what you're looking at relative to the dewatering capability differential, the actual ability to create changing speeds between the flights and the screen as they relate to each other is really what defines the difference of a classic dryer versus the new modern direct dual drive dryers. And that's because we operate at a very low differential typically with our direct drive dual dryers or direct dual drive dryers. Apologize. All those D's make it sometimes a little bit of a tongue twister. But the fact is that where a typical dryer, or I should say a classical dryer, operated between 13 and 16 RPM differential, we're operating differentials classically down to 6 RPM within a modern direct dual drive dryer. And if you think about that, that means the scraper flights are moving only 6 times a minute around the entire circumference of that screen. So that basically means it takes 10 seconds for that flight to make its way all the way around to the opposite side or to come back to its original position. And that is a big key difference in regards to those classic dryers and allowing a cake wall to build up. And we're going to talk a little bit about that here even in more detail. But that also is part of the reason why the newer dryers end up having dramatically less degradation effect when it comes to any impact on the cuttings and the prior misnomers associated with the damaging of cuttings. And I shouldn't call it a misnomer because technically those classic dryers certainly do have a much higher propensity for damaging and degrading cuttings than the new direct dual drive dryers. And then of course, rocks are hard and dirt is dirty. So the last really basic fundamental design element in regards to a vertical cuttings dryer, besides of course, how you apply the G-force, how do you get the right residence time, and how do you generate the differential that's needed to ensure a good dewatering and residence time, is how do you keep a dryer that is cleaning rocks for all intents and purposes from breaking apart and falling apart within a matter of days. And that really comes down to a major part of the engineering that gets imparted into the design of our vertical cuttings dryers. And I shouldn't say just our design. I mean, all vertical cuttings dryers really should go through that level of work where you're designing the interior surfaces of your launder sections, or where you're collecting your solids or discharging them from the bottom of the vertical cuttings dryer. There should be very large volumes of ceramic tiling. Even when it comes to our flights, many of our flights today are going to be at a minimum hard chrome, even though we actually used to provide a casted option. We actually killed that many years ago as a result of how quickly they get eaten up. So now our base level is a hard chrome flight, but even from there, we've got then ceramic and tungsten carbide tipped. And then even our screens, which I don't think we spend enough time talking about this, but our screens are hard chrome dipped themselves. And so they're provided an additional level of abrasion resistance, and that even though they come looking all shiny and steely and stainless steel, even though it is a stainless steel screen, that stainless steel screen is then hard chrome dipped to provide a higher level of abrasion resistance. And one of the reasons why we tend to find a longer lifespan with screens that are hard chrome versus those that are not. So all of that is basically essential to the fundamentals, the basics of a vertical cuttings dryer. However, when we look at the application of vertical cuttings dryers, it really is driven by the interconnected financial and environmental objectives. For many, many years, it was really either taken as one or the other. And you would find that in some cases, people would look at this as, how am I going to end up saving money from the deployment of vertical cuttings dryer, to how am I going to go ahead and reduce my wastes, or how am I going to reduce my spend for drilling fluids? You really have to look at this as a combined effect. And really, that's probably one of the biggest pieces of misinformation and misnomers out there, is that a vertical cuttings dryer, though it is truly an excellent resource at providing a reduction cost for a drilling rig, especially in conditions in which you've got high oil prices, especially as we see our world today, or when you have very expensive drilling fluid that have been designed, or drilling fluid systems that have been designed, or you've got areas in which disposal costs, because of transport or the local regulations or whatever it might be, may make it very difficult to go ahead and move that material to that disposal site. So even if you've got a water-based fluid that you're removing into watering cuttings, it may be very, very expensive to have to go ahead and dispose of that material, depending on the area that you're in. So when we look at this, you have to look at the interconnected financial and environmental objectives. So our goal, of course, is we want to reduce the drilling or construction fluid expenses. We want to reduce the volume of material need to be used. So we want to reclaim what's there. Fundamentally, all industries need to be making that push towards making a improvement in their reclamation or recycling of the fluids that they use, whether that's in micro tunneling, whether that's in oil and gas drilling, whether it's water well, geothermal, pipeline, fiber optic. There's a lot of industries that use various fluids. Foundation drilling is one that is starting to see a lot more activity in this particular area. And all of them spend a lot of money and time building out those fluids, and to recycle that is a key element. Waste solids reduction is a major financial selling point when it comes to being able to reduce your costs. The idea is that if you dewater your solids, you're going to be able to get much more per load into a truck. So whether or not this is an oil-based solid, a water-based solid, whether it's from the pipeline industry, or from the dredging industry, or from hydrovac excavation, it really doesn't matter. At the end of the day, the goal is to be able to go ahead and have a significant reduction of volume. However, the bigger thing which does affect and is more important for many is the solids waste classification or declassification. What we know here in the United States is something called the paint filter test, or a T-clip. The T-clip is total toxicity leaching parameter, and that basically is an indication of whether or not you have to take it a certain type of lined landfill. And in the United States, if you have to take it to a lined landfill because it has high liquid content, then you end up in a situation where you got to spend a lot more money for disposal. When you dewater the solids, you will certainly be able to go ahead and take it to a non-subpart B lined landfill, which gives you a lot more options. However, in water-based applications, there are a lot of parts of the world that will allow you to directly land farm that in the local vicinity or the site that you're working in. As long as you have stabilized solids that can be compacted and you've dewatered it completely, you have the ability to land farm that material. And so we have several customers that are deploying vertical cuttings dryers specifically for the purpose of being able to land farm those solids without having to transport them off. And of course, that really is dependent on the local regulations and the nature of the fluids that you're dealing with. But as an example, when we look at this, when you look at the financial and environmental objectives, if you were to just take a typical prototypical oil and gas rig, you can lose up to 5 gallons a minute of drilling fluid. Over a 20-day or 20-hour day, assuming 4 hours of downtime or whatever it would be on that rig, you'd be losing about 6,000 gallons or 143 barrels. And if you were to go ahead and just look today, even though I know it's been fluctuating all over the place, but the fact is, even if you used $100 a barrel times that 143, that's $14,000 in fluid losses that could be accounted for every single day that you have those fluids being excavated or expelled with the cuttings that would be untreated. And this is not unique in regards to the markets that we are dealing with. And I talk about the oil and gas just as an example here, but you have to consider this for all markets that have engineered fluids that they're utilizing to make, the hole or to keep the foundation open, or any scenario in which you've got solids that have to be dewatered to declassify them or to compact them, land farm them. There's a lot of variables that have to economically considered. And I will say that we do have a number of economic models. And anytime that they have customers or individuals or people that are deploying such systems, please don't hesitate to reach out to our team, because we can provide you quite a bit of details when it comes to what that would look like or what those financials might end up evolving to. Relative to typically a vertical cuttings dryer, this had been a competing technology to a drying shaker, which really had been the predominant technology that was used over a number of decades. And you typically have a scalping or core shaker that would be utilized, and then from there you would then feed the drying shaker to go ahead and recover as much material as possible. And then that evolved, of course, as of 20 years ago in several of the industries that we work in, to the vertical cuttings dryer. And so now we're seeing more pressure going towards the vertical cuttings dryer versus drying shakers, just simply because the drying shakers cannot get down to the levels that a vertical cuttings dryer can in regards to truly dewatering and providing you a dry, compactable solid. And so that's the important thing to see. And when you look at the little bar graphs below, that gives you a comparative perspective of what you're going to see from the, in fact, here you've got OBM, which would be oil-based mud, oil uncuttings, and then you get WBM, which would be a water-based drilling fluid, water uncuttings. And so that shows you the comparisons that you would get between an oil-based fluid that would have high slurries versus a water-based fluid that would have those solid slurries or suspended solids within it. But this is a great example to kind of highlight the difference between the different capabilities of those different dewatering systems. Classical application vertical cuttings dryer within a closed loop system had previously been where you'd use a vertical cuttings dryer in oil-based applications, but drying shakers relative to water-based applications. And this could be used in a number of scenarios, whether this is, again, a refinery application, a sludge cleanup application, whether or not we're talking about a dredging application. This could highlight a prototypical application where you've got a slurry that's sourced in the red box. It's going through the scalping shakers before you get to one of the dewatering systems. And then you may have a dewatering application that comes off of the water-based, and from the oil-based side, you would end up going through decanter centrifuge, one or if not two, depending on the market or the industry that you're engaged in. So this would be a typical pattern that would be there. And that's what has evolved quite a bit since the evolution of the direct dual drive dryers, which we'll talk about that and how this changes the overall model here in just a moment. Really, the problem with the classical fixed speed dryers is the fact that it was fixed speed. The fundamental nature of it is that when it was deployed properly, it performs admirably, and it really does. I mean, it is a workhorse of a package. Has done an amazing job over that period of time, and really has been a product that has created a great reputation. However, that same vertical cuttings dryer, when deployed improperly, can perform abominably. And so that's really kind of the nature of what's kind of unfolded in a lot of the markets that we've seen over the years, is that the deployment of fixed speed dryers in certain applications can actually result in pretty nasty effects. And that's really where we want to kind of talk about some of the meat of what we've been talking about here, the myths and misconceptions of vertical cuttings dryers and how they've evolved. And so a lot of those periodic deployment failures have indeed tarnished the reputational standing. I apologize here. Obviously, we've got this thing set up here on automatic forwarding in the slide, so I got to keep backing up. But for the VCDs, first one is VCDs are expensive to deploy. And we've heard that quite a bit in comparison to drying shakers and other elements. The reality is that at one point, the vertical cuttings dryers were definitely more expensive. And we'll talk a little bit more about the fact that the actual pricing, despite the nature of what's happening in the market, we're actually selling vertical cuttings dryers today far less than we were probably 10 years ago. And that has a lot to do with the design, the work that's been put into it, how they've evolved over time. And it's pretty impressive to see how that has happened. But I will say the big thing here is that the operating expense of vertical cutting dryers is dramatically lower than that of drying shakers. And that's because, of course, the screens are less fragile and you get a lot more life out of them than you do the replacement screens within a drying shaker. Next item has been that VCDs are difficult to maintain. And this comes about as due to the number of components and replacement parts combined with the tendency to plug. And it was really one of those things that you saw a number of personnel that were required to operate that vertical cuttings dryer, requiring them to shut down frequently to clean the dryers out. The fact was that there was a lot of spare parts and consumables that would be required, and that made it very difficult to kind of keep up with equipment. And it's still used that today. I mean, most of the vertical cutting dryers that are deployed in the market now are those classic vertical cutting dryers. And that operator expense and that effort to maintain certainly increases the cost of ownership for those classic dryers compared to the more modern dryers. The next item is VCDs can create hazardous conditions. And the reality is that is relatively true with a classic fixed speed dryer. We've got a lot of scenarios that we've been involved in that the dryers were operating at such a speed or creating such a level of dewatering that in an oil-based application, it can create an oil mist that would create basically a glazed work environment where everything's covered in oil, which makes it a slippery environment and or could be considered an oil spill into itself per local regulations. And that's because if you don't have a dryer that doesn't have the ability to adjust that differential and that speed, that can very well happen. And you could end up creating great dust clouds and everything else. And without those adjustments, that certainly had been a prior challenge. And then you've got, of course, VCDs have an operated window that was limited. And again, that was driven by the fact that we had a vertical cuttings dryer with a fixed speed output, fixed differential, didn't have the ability to be able to modify basically the nature of how the solids went through the dryer and how it was fed. And again, there's a big difference between a classic dryer and the fact that it's trying to basically sweep the screen free of any solids as fast as it can versus the direct dual drive dryers, which actually is trying to maintain a filter cake on the screen surface, which is very important to the distinction of how the two vertical cuttings dryers perform. And that's also one of the reasons why we can actually achieve a much finer cut and get a much bigger operating window with the newer dryers. We'll talk about that, of course, more. Other areas of just misinformation and fake news is that VCDs have very little value with water-based mud. And the fact is that, as I noted here just a few minutes ago, you have to take this into effect relative to the concept of not just the environmental effect, but the financial effect. And at one point or time, water-based fluids tend to be quite inexpensive, and water was also just readily available and not a problem. But over the last several years, not only is there a priority to water recovery, but water-based fluids have indeed become a lot more expensive. And so today, water-based muds or drilling fluids or engineered fluids are certainly a much more susceptible and a necessary thing for vertical cuttings dryers. The next item here, VCDs generate excessive fines. We hear this very, very, very often. We've done, and there's been countless tests, and it's crazy to see the number of data points or the misinformation that's been kind of put out there that a vertical cuttings dryer is degrading my solids and creating lots of problems, and it's actually generating this massive plug of ultrafines that's going back into the active mud system with those recovered fluids. The reality is that a vertical cuttings dryer, and I'll get into this more here just in a minute, is actually not generating or creating those fines or ultrafines. It is consolidating, it's concentrating them. And we'll actually get into that more and talk about that. But I will say classic vertical cuttings dryers did indeed actually generate fines as a result of the high level of scraping action and the fact that it was not generating a cake wall to protect the solids. And that is a very different scenario to what is actually in the direct dual dryers today. Next item is VCDs fail to recover enough drilling fluid. And the reality is that can be the case, that if you're operating out there and your flow line shakers or your coarse shakers or your sculpting shakers are getting you already down to 10%, can you economically justify going down to 3 or 4% water or oil on cuttings by deploying a vertical cuttings dryer? I think that as we've evolved and we've now have the ability to really tune up and get that G-force and that residence time, that really has changed the landscape with these new modern direct dual drive dryers. But older dryers, it certainly was a challenge trying to tune that in without making significant changes to shivs or the belt configuration, or having to modify the system by adding maybe an additional VFD, which only increased your differential even further and caused your actual flights to increase in speed, which didn't really help you all that much if you have increased G-force, but you're now reducing your actual residence time. And then finally, VCDs can't clean cutting sufficiently. There's always this concern that we can't get down to less than 1%. And that is true. A vertical cuttings dryer is not going to get you down to less than 1%. But that is not necessarily what the goal is here. Remember, we talked about that idea of getting to a stackable dry solid that could actually go to landfill for caps and or be easily transported. And that's where the target needs to be looked at and focused on relative to the economics. So lots of things to consider here, but between this last slide here and all the issues about being expensive, difficult to maintain, the hazardous conditions and the limited operating window, and we look here, just to the value and ability to recover enough or utilizing it in enough applications between oil-based or water-based, or if it's creating problems with the fluids by putting fines back in. All of these are items that really have evolved as a result of the history of that classic vertical cuttings dryer. So now, moving this over to the modern direct dual drive dryer, that's where we kind of get in this idea that we've now got this independently variable G-force and dewatering residence time that creates variable filter cakes based on the overall design of the system. And that filter cake and the ability to adjust that is really a new paradigm in an operating design for a vertical cuttings dryer. As we've been talking about, the clasp dryers do not build up a filter cake. They try to remove the solids as fast as possible with a high differential speed. A direct dual drive dryer adjusts the filter cake that builds up and accumulates on the screen in order to create varying levels of filtration. And that's a very different means of being able to dewater something than utilizing just the screen itself. Instead, we're using the screen as basically the bed that supports all of the cuttings that build up on it and that become the filter media itself. So when we look at the features associated with modern vertical cuttings dryers, I'm really going to kind of keep it just to this one slide because, again, I don't want this to get overly burdened down by some sales pitch to this. But it is important to keep in mind that a direct dual drive system eliminates all belts. And that is a big deal in regards to maintenance and service. So you have no belts, no shivs, and it makes it truly a Class 1 Div 1 and Class 2 Div 2 or Div 1 compliant system. So if you've got explosion-proof environments in refineries or on a drilling rig or in a oil-based sludge cleanup environment that you need to have explosion-proof equipment, it is truly an explosion-proof device. The fact is that the classical dryers are all belt-driven, and there is a lot of conjecture in the market as to whether or not a belt-driven system can ever truly be a Class 1 Div 1 system or Class 2 Div 1 system. So that's a big point to this. Second one, of course, the differential makes all the difference. The differential is a fundamental element of it. It's really all about building up that cake wall, and the VCDs are able to tune what you want to achieve out of the vertical cuttings dryer. And it's very important that you see that difference in what you get from a class dryer versus those modern direct dual drive dryers. The next item, which we kind of highlighted a bit, is driving down those direct costs. Again, you're eliminating belts, you're eliminating sheaves, the traditional oil system, the oil pump, the oil reservoir, the oil filter, the flow switches, the oil flow or pressure switches, all that's gone. And that is a huge item. In fact, that's when you look at the history, which I must admit, and I'll say this, digressing a little bit as an organization that actually does sell equipment and spare parts, 75% of the service requirements when it came to our classical vertical cuttings dryers were the oil pumps, the oil filter, the flow switch, or the pressure switch. These things require constant support and maintenance, well, including, of course, the belts. And by eliminating all that, 75% of the service requirements have been eliminated on a dryer. And we've seen from one customer to the next that the actual operating costs, the amount of actual expenses towards spare parts and consumables, have dropped 46% from a classic dryer to a direct dual drive dryer. So that is a huge deal when you think about the overall economics of a dryer from a classic dryer just 5 years ago to a new modern dryer. Though there's a little bit higher front end cost, to be able to lower the operating cost in spare parts and consumables by 46% on a per annum basis is a really impressive deal. And I got to give props to the engineering team and all the work that they put in to make that happen. And then finally, we did end up making a completely new design within the modern direct dual drive dryers by eliminating a lot of the obstructions within inside the dryer. The old dryers had that massive belt tunnel. Actually, as you see a representation of that to the far left there, the new ones do not have a big belt tunnel. It's not this big flat belt tunnel that covers 30-40% of the below discharge surface. Instead, we've got these very economic, or I'm not sure, economy of scale, I'm not sure what you'd call it, but very compact belt tunnel or drive tunnels that go from both of the motors directly into the gearbox assembly. And they've got sloped roofs on the top of them, and the combination of those small shaft tunnels with that sloped roof that's been provided allows us to dramatically decrease the amount of obstruction within a vertical cutting dryer by 70%. And so now dryers can go a much longer and have a lot less problem in regards to plugging and having to deal with solids buildup what's inside the dryer. So now when we've got the modern direct dual drive dryer, we end up with a situation in which the modern application ends up with a vertical cuttings dryer that can handle both the oil-based and the water-based applications. And basically you change the dynamics of that completely. And with the dewatering systems, and this is something we're going to talk into more in the next session, and I'll kind of give a little bit of a plug here in the fact that this is something that we as an organization will be doing on a monthly basis. We're going to cover different topics and cover different areas of the industry. And the next topic is going to be on the challenges of deploying or effectively deploying dewatering systems in order to remove ultrafines and colloidal solids. And we're going to talk about that both within the context of oil-based environments. That would be a two-step process that would start with a surfactant or a microemulsion and then go towards the utilization of dewatering polymers, or a water-based application that is just polymers. But dewatering and the utilization of polymers and or combination of surfactants is a big part of what we're seeing growing in the industry. It's something that we've got a lot of questions that pop up all the time, and we thought that it would be great to have the next session on that particular technology. So we'll be doing that. But this streamlines the overall closed loop process when we look at vertical cuttings dryers and the deployment of them and utilizing this more modern technology versus those classic dryers. So relative to the proper deployment, we look at those myths, misconceptions, and some of the challenges. There are a number of bridges that are provided with this newer technology. And that is when we look at the items there between this last slide and this slide here, we were really going back and forth between all those myths and misconceptions that we talked about at the beginning. And VCDs are no longer expensive to deploy. Again, we're actually operating maintenance expenses by 75%. We've lowered the capital equipment prices dramatically on that. And this is happening at the same time that the cost of screens and other scalping equipment and dewatering equipment have come up. And so there's now a higher level of return on investment that has ever been seen in regards to the deployment of a vertical cuttings dryer. So even where if it was in a classic dryer, the newer dryers with the direct dual drive system will give you a much higher return on investment as a result of the ability to reduce those costs and to be able to maintain a much more dry and dewatered solid. VCDs are no longer difficult to maintain. The reality is when you remove 70% of those obstructions and you've removed all of those spare parts and consumables, the oil pump and the oil filter, the oil reservoir, all the oil lines, the pressure switch, the flow switch, it makes it just so much easier to maintain that vertical cuttings dryer, because now you're basically dealing with drive shafts. You've got planetary gearboxes that are sealed for life for all intents and purposes. You're not going to end up servicing your gearboxes unless, of course, you end up having a major situation in which you end up blowing out their vertical cuttings dryers, overloading it or feeding it or dropping in there a boulder or something of that nature. But the fact is, in a normal course and scope, it is a very durable piece of equipment and very low in regards to the overall preventative maintenance that's required. We now have the ability to mitigate all of those potential hazardous conditions. given the ability to adjust G-force residence time, the overall filter cake capabilities, the parameters that govern its operating system, we can now ensure that a vertical cuttings dryer does not create an oil sheen or film in the local area, does not create a dust cloud. So that is another key element that is done. And then now we have a huge operating window. With a direct dual drive dryer, you can handle both, of course, as it was before, it was almost predominantly oil-based. We can now handle oil-based and water-based, no problem whatsoever. We can handle suspended solids down to 30 microns, or even up to 2 inches in size. We'll talk about this 30 micron element here just in a second, because keep in mind that the actual screen size that's usually inside of our vertical cuttings dryers tends to be about, I'd say, 500 microns in size. And you'd be like, well, how can the screen that's 500 microns get you down to that 30 micron cut? We'll talk about that here just in the next slide. And then we can now handle we can handle moisture contents as high as 90%. It used to be that vertical cuttings dryers had to operate within a relatively tight band. You typically were looking at things that would need to be at least 20% moisture content to make sure there's enough lubricity and to move the cuttings through, and that you had it maybe 50% at the high end without flooding it out and making a lot of problems and just having whole mud losses coming straight through the vertical cuttings dryer. Now we can, because these differential capabilities, because of all the different things we're doing, the filter cake, we're now able to handle slurries that are as high as 90% wet. And that is a big deal when it comes to the number of applications that you can put this in. So when you look at the fact that now it's not just oil-based, we can have now 30 microns to 2 inches or 5 centimeters and handle moisture content up to 90%, you have a large operating window there. So the next one here is when we look at the generating value for the water-based, we now see that, there's lots of great applications here in regards to the vertical cuttings dryer. And we've got, not only is it, creating value for the water-based environments that we talk about, I think this comment about it's concentrating fines, not generating fines, really comes around as a result of that cake wall filtration capability of the direct dual drive dryers. We're really allowing that filter cake to build up, and then we basically scrape off that cake in large lumps, which means you're not actually going ahead and having this grinding action against the surface of the screen. You're actually going ahead and slicing behind these layers of the cuttings that are there, which is then dropping those cuttings through the vertical cuttings dryer and allowing that to actually become the filter cake. And so we are concentrating whatever fines might be in the fluid, but again, we are grabbing a lot of them, a lot more than the classic dryers would be, because we're now using that filter cake methodology versus whatever is that slot size of that screen. At one point or time, if that slot size of the screen was 500 microns, almost everything less than 350 microns would go right through the screen. Based on the rotational speed and some of the physics, you'd end up getting a actual particle size distribution window that would be lower than the slot size. That would be about 350. Now we're seeing that it's much lower than that, and that we're getting things that would end up showing up that you're at 200, 100 microns versus a classic dryer that used to end up allowing things that would be as high as 350 microns. When it comes to the actual physics of the, I guess you could say, the surface tension of fluids and what we see, and people ask all the time, well, how far can I go in regards to dewatering my solids? You really should assume 100% of your free moisture is going to be removed, 99% of the surface wetted moisture, and about 50% of the interstitial. The big problem here is the interstitial moisture. Interstitial moisture is really that moisture that finds its way inside the solids, and kind of like a sponge or a rock, or I should say as a sponge, and it brings it inside. No matter how much G-force you apply, it's kind of cupped inside the solid. And it's very hard to remove that interstitial moisture. And that's what governs the difference in regards to what the percent solids may be. In fact, in many cases, you may see a pile of solids coming out of vertical cuttings dryer, and it looks like just dry, just perfectly dry solids. Yet the reality is that the interstitial parts of that solid really do end up having some absorption into it. So that's just something to keep in mind. But really, vertical cuttings dryer will remove 100% of that free moisture, and that's a big part of what's being pulled off of out of that liquid. And then, of course, at the end of the day, as we talked about, when it comes to sufficiently cleaning solids, those direct dual drive dryers, when deployed correctly, can bring you down to the point where they can get very dry solids. They'll pass that paint filter test or the T-clip test be able to go to unregulated or unaligned facilities and or be used for cap. And in many cases, you're going to find opportunities for land disposal using water-based applications based on the permitting and the legislation in various regions that you may be in. So again, lots of interesting things that can actually be deployed, but it really does provide a lot of those bridges in regards to the technology. So the last item here that I think is very important and the noteworthy items and the fringe benefits of the vertical cuttings dryers. When we talk about those myths and misconceptions, it really is important to realize that right now, the industry is still searching for ways, whether you're hydrovac, whether this is foundation drilling, dredging, oil and gas, micro, tunneling, HDD, all these industries have a responsibility for further advancement of the environmental responsibilities and what we can do to end up reducing the disposal and the waste generated. And that just becomes this fundamental element of everything. But I think that there's still more that can be done in achieving performance above that a vertical cuttings dryer provides. The first one is on oil and gas rig flow line shaker performance. Far too often, rigs will have very coarse screens because they are worried about whole mud losses in that industry. And you do not need to do that when you've properly deployed a vertical cuttings dryer. You could have fine screens, you could have very large volumes of whole mud losses coming off the shakers, but that ends up meaning that you're getting a lot less fines in your active mud system, and you're allowing the vertical cuttings dryer to recover those that fluid. And even if that fluid now has those fines that would have gone into the active mud system straight through the scalping shakers or through the flow line shakers, every vertical cuttings dryer is paired with a high-speed decanter centrifuge. So by doing so, you're actually able to go ahead and keep a much cleaner drilling fluid by going ahead and adjusting the actual screen that are being deployed. The next item thing is anywhere that you see hydrocyclones being deployed, if you've got the ability to blend the hydrocyclone underflow with coarse cuttings, you do have the ability to go ahead and dewater those hydrocyclone underflow. And when you think about the 4-inch or 5-inch hydrocyclones operating down to 30 micron cut, we've got a number of applications that we've seen in which individuals have been commingling those solids directly in with the scalping shakers, and they have successfully been dewatering those cuttings that are coming off of those those shakers that are on the hydrocyclone systems. And that's a very interesting artifact. We hadn't originally presumed that was the case or the goal when we started developing these new modern dryers. But the reality is that when you really think about the overall perspective of what this can do or how far it has gone, to get down to that kind of a micron cut by using that filtered cake methodology is pretty impressive. Another item is in the waste treatment arena in the industry, we talk about enhanced tertiary treatment. This is really all comes down to thermal desorption or other type of incineration technologies. There are a lot of areas in the market that vertical cuttings dryers are used in various hazardous wastes or other areas in which you've got to take it down to a level in which there's no perceptible levels of TPH or total petroleum hydrocarbons, and you have to use thermal desorption to be able to achieve that. To be able to utilize a vertical cuttings dryer effectively prior to a thermal desorption system will actually reduce the energy input required for that thermal desorption system. And so that's another key item that is kind of overlooked out there. And then, of course, we've talked about this a little bit, the application, the ability to land farm cuttings. If you've got areas that you've got water-based or you've got cuttings that don't have any hazardous components that have been put into it or the drilling fluid, you now have the ability to go ahead and get a dry stackable solid. If it's got less than 3% moisture on it, you're going to be able to go ahead and plow that into the field or in the area that you're working and be able to go ahead and leave that in place. And again, local regulations are going to dictate, but it's something that we've got a number of our customers that are taking advantage of by deploying that vertical cuttings dryer. So again, these are a number of just fringe benefits, key things in the industry and things to think about beyond just the fundamentals of a vertical cuttings dryer itself. Final parting thoughts, and really, I think that this is important and kind of the basis of this conversation, the reason we're doing the discussions of this nature, and we'll continue to do so for the next several months and on a monthly basis, is that there's this link between employee education, equipment efficacy, and environmental equity. And really, I do consider, when we look at the world that we live in, we have a responsibility, not just to our employees, but to our own bottom lines, to make sure that the equipment is doing what it needs to do, but to the world that we live in and the environmental equity of the things that we do. And so with all technology, I truly do believe that the effectiveness is inherently limited by the quality of the personnel we entrust to deploy and operate. And that quality of those personnel comes down to having education and putting that information out there. The more that we do to educate, certify, and retrain our most valuable assets, the more our organizations, the world we live in, will benefit. And I apologize for this being the one slide that I will read directly off the page. But I think it's important that we all look at this and we recognize that the importance of good training, good information, good certification, and understanding the benefits that such technology can provide. So I do apologize. It looks like I've taken 2 minutes extra that I thought I would take, but it looks like we're pretty much right on time. So I guess at this point, I will move this over to Mr. Ray Petramali, who I think is monitoring or engaging relative to any participants out there that might have questions.
Okay, thank you very much, Mr. Anderson. Really appreciate you taking the time today for this presentation. If you have a question, please raise your hand and we will get to you. There was one question through the chat that I had from Tiana Zhang. Said, not sure I missed anything relative to the comparison between dryer and vacuum shaker.
Oh, that's actually a very good question. And actually, we probably need to go ahead and extend this conversation. I just didn't have enough time. Honestly, when we look at the nature of the people that we got involved in this call, attention span is key. We try to keep these things at 45 minutes. But you are right. We need to go ahead and extend the presentation and start talking about the vacuum enhanced shakers. These have actually done much better as a drying shaker in the market. And it was the next step in evolution to those drying shakers that were out there. There was a couple of technologies that have been deployed over the last decade with some varying levels of success. The challenge has been the maintenance and support of the vacuum systems that are required to support those vacuum shakers. And the operating costs are very high, as well as the capital costs. But I do appreciate you bringing that up, and we'll certainly expand on that more and make sure that as we go ahead and evolve this presentation and or we look at future iterations, we'll include that discussion also. Thank you for bringing that up.
Okay, you are more than welcome to submit a question through the chat box if you'd like, or you can raise your hand. We really appreciate you all taking the time. I know for some in attendance, it is evening, and for others, it is morning. So really appreciate everybody joining us today. I do not see any questions at this time.
Well, that's very good. I mean, I will admit, there's a lot of material here and a lot of information. If you do have questions, please don't hesitate to go ahead and send them on in. I know that we're all busy individuals and there's a lot to digest. I certainly am not, arrogant enough to believe that I've covered every possible question that was out there. But don't hesitate if something pops up or something clicks into your mind. We certainly will be able to follow up with you. And Ray, I think we're going to we have everybody's email address so that we can forward them out the presentation.
Yes, we do, and we'll get into that in 1 second. We have a question from Ken, who is asking, could you elaborate on capacity and sizes of the VCD?
Oh, very good. So right now, vertical cuttings dryers, I'm trying to make this not Elgin specific, but there are, when we look at it, we call it the 3 series, we have the 4 series, and then we've got the 5 series, which actually was just recently deployed and put together. And we've actually not had a chance to really get it out there to start vetting it out. Because we're really excited about this increased size and the capacity, especially when we see the volume of cuttings that are coming out of a number of applications and markets that we've been starting to engage in. But the 3 series was really the smallest dryer, and there are a number of copycats in the market. That dryer is indeed about that 30 tons per hour, and it can go up or down from there. In fact, it was previously rated as a dryer as about 40 tons per hour maximum capacity. We today call that about a 30-ton unit, and it can go up or down from there. And I will say our actually newer version of the 3 series, which is the E3, actually uses a brand new 3-stage gearbox, which takes advantage of this new direct dual drive system by not having the oil lubrication and everything else, it actually has a higher G-force and a lower differential speed compared to the classic 3 Series dryers, but it also provides a higher torque. So we've been able to see a lot better performance utilizing the new gearbox technology in that classic body format, even though you don't get the differential capabilities and the independence of the VFDs and everything else. It's really been an improvement. Moving on from there, you got the 4 Series, which was probably the most copycatted vertical cutting dryers in the market. I think there's probably about 6 different companies right now that are providing a vertical cutting dryer utilizing a screen with the exact same diameter of the screen that we're utilizing. And that was classically noted as an 80 ton per hour dryer. And that dryer we now classify as basically being a 60 ton plus or minus 20 ton. And that dryer is still a workhorse of a unit. That's the D4 series. In fact, what you see there on the screen right now is the CSI D4, which is the iteration of the 04 series that have been around for many, 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 many years. And then now we have, as I was talking about, the 5 Series. And the 5 Series steps us up where, before we were talking about 40 tons per hour maximum capacity at the 3 Series, 80 tons for the 4 Series. The 5 Series brings you up to 120 ton maximum capacity. And we actually consider that to be a unit that would target about a 90 tons per hour, but it has a maximum capability of about 120. And that unit is the latest unit to be able to come to the market. So now we have the 3, the 4, and the 5. I do not believe that there's anybody building a 5 Series dryer for the markets that we engage or talk about. I know that there are 5 Series dryers that are used in the coal industry, and there's some in aggregate, but not many that would be at that size or larger. So that 5 Series is something that we're pretty excited about. And I will say, and the important thing to keep in mind here, the actual tonnage is more based on the actual solids input than it is the combined effect of the liquid and the solids. Now, it does change relative to viscosity and a lot of the other things that you might deal with regards to that balance between the liquids and the solids. But fundamentally, we've seen people inputting far greater on a mass balance than, let's say, a 4 Series dryer than that 60 tons per hour, 80 tons per hour, when you consider the fluid and the solids. But the dryers are actually rated based on the solids input, not the slurry input. So you do get a much higher capacity than just the simplicity of what's coming in on the slurry basis. So that's where we sit in the market today. And I think relative to when I think about the competitive landscape out there, and to give credit where credit is due, they're all going to fall within those categories in addition within that 3 Series, 4 Series, or 5 Series. Good question. Thank you.
David has asked a question. Can you please touch on the difference between fresh and legacy cuttings?
Yeah, this is an interesting concept. Fresh cuttings have high, I talked about the presentation that there's 3 layers of moisture to a slurry. You have the free moisture, you have the surface wetted moisture, and you have the interstitial moisture. As cuttings age, the surface tension of the surface moisture goes up and the interstitial moisture skyrockets. It goes dramatically up. And that is as a result of the capillary effect, where as time goes, the solid actually ends up breaking down in a bit, and it almost allows that oil or water to make its way into the cuttings much more deep than you've got with a fresh cutting. And so as cuttings age, the ability to remove out the interstitial and the amount of energy required to remove the surface wetted fluids is much, much higher. And that's why we will typically see that with a fresh cutting, you can get down to, if you're on an active system and you're going ahead and having solids going directly into the vertical cutting dryer right off the operating system, you're going to get down to 2.5%, 3.5% oil on cuttings or 5% water on cuttings. But if it's aged, it may be double that because of the volume of interstitial fluid. So yes, it certainly is an issue, but it all comes down to that interstitial fluid and that higher surface tension that gets created as a result of the legacy and the late age that cutting has been, or that the age that the cutting has been allowed to exist. So good question. Another one.
Okay, we have a question from Alexander. Have you ever considered clean in place on the shroud to clean screen without removal of the shroud?
Yes, we have. In fact, we used to end up doing so. We had a technology for such, and we did deploy it. And I guess this is one of those rare occasions where I'll be very transparent. It was a miserable failure. We put that technology out there. We had a clean in place system. And what was happening is that not only did it get clogged up quite a bit, but the rotational speed of the screen and the fact that the screen has, let's call them rigid stabilizers on them to account for the G-force. Basically, I've got this effect called hoop stress that causes the screen to want to expand. And so we've got a whole bunch of cages and different elements to the screen that provide ribs or reinforcement ribs. Well, those reinforcement ribs at speed create basically an envelope around the actual screen itself that the air knife or the hydraulic cleaning system would have a very difficult time penetrating. And I know that's a physical concept and trying to get that in your head, that you've got this air envelope being created around the exterior of the screen, and you're trying to penetrate that with an air knife or a fluid spray. The actuality was you'd have to put in so much energy or so much fluid by volume that you'd actually overtake the amount of volume that you're collecting based on the amount of volume you have to clean the screen with. And we see some of our competition putting out such systems, and we see it as more of a gimmick because it's not really doing a lot of actual cleaning. But I will say we are finding today that the direct dual drive dryers, because you're actually creating a filter cake that's sitting on the screen surface, you actually have a lot less blinding than you do before. Because before, the grinding action of the actual scraper flight would drive solids into the slots of the screen and create more of a challenge when it came to buildup of solids. Again, there's a lot more to this conversation, and I'd love to go down that rabbit hole with everybody for another 20 minutes. But yes, we did indeed try to do that. And though we may end up revisiting it, I can safely say it with all humility, that was an area that application did fail on our behalf.
Okay, we have a few more questions as we're here for just a few more minutes. One question I can answer, Ali, you asked a question about more information with polymer separation. We will be hosting our next webinar next month, third week of April, that will discuss polymer injection separation. Also, we will be making this presentation available through our website. So give me about a day and we will get this up onto the website, and we'll send out an email to everyone where you can download this presentation. Next question is from Roman. Is it any difference in VCD direct drive performance comparing freshwater mud or inhibited water-based mud? Did we lose?
Yeah, I don't know, Ray. So for some reason, it doesn't want to give me that access to go ahead and turn on my microphone. So I was sitting there talking and I couldn't say it. Even nobody heard me.
We hit the 1 hour mark and it canceled out. So
yeah, no, it's all good. So yes, inhibited fluids by design, and in case nobody's heard that term, in case there's people that haven't heard that term, inhibition is the design engineer of a fluid that resists the ability for solids to disperse in solution. And it is the ability to basically keep the surface tension low, that you don't want the liquid or the fluid to bind to the solid. So the combined effect of this reduced surface tension combined with resisting the desire of very fine solids to resist or move away from each other is what we call inhibition. And yes, the more inhibited a fluid, the much higher of performance you're going to get out of a vertical cuttings dryer. And that's why water-based applications, which typically end up having lower levels of inhibition versus oil-based applications, end up getting less less dewatering can be achieved. And so again, it does define, so many differences between the geology of the solids and the nature of the inhibition and the type of the fluids. It's so hard to govern and know exactly what you're going to get. We get that all the time. Well, what am I going to get out of my vertical cuttings dryer if I apply it in this scenario? And honestly, we guess. We have a lot of good history. We put out 900 vertical cuttings dryers to date. We know exactly, what we can expect from different environments, but it's hard to judge based on those varying levels of inhibition and the nature of the geology. But yes, inhibition does have a significant effect on the actual dewatering capability. The more inhibited a fluid, the much higher the dewatering capability is.
Okay, 2 more questions and we'll wrap up. Prasad asks, what is the power requirement since we are using 2 motors?
Oh, very good question. Actually, I'm glad somebody asked that. We're actually using the exact same power requirements of the original classic dryer. If you think about the typical, let's say the 4 Series. The 4 Series uses a 75 horsepower main drive continuous duty motor on the like our CSI 04, our classic dryer, or even the CSI E4, which is the newer version with the upgraded gearbox without that lube system and everything else. Those dryers use a 75 horsepower, very large motor. When we look at our D Series dryer, I guess you'd say the sister to that, or the upgraded new evolution of that, you're using a 60 horsepower main drive and a 15 horsepower back drive. So you're using the exact same horsepower that you had with the classic dryer with the new modern dryer. So I should have made note of that we actually are not actually inputting more energy into the system to accomplish the same thing. So good question.
Okay, last question from Bonnie. Does the new VCD come with stand or a client can fabricate on site?
Oh, I should never admit this. Our vertical cutting dryers, we do have our own stands, and I don't, but I'm going to take away from this. Elgin, we are a great engineering and design organization. We build, I think, fabulous equipment. I love what we've been able to do with this technology, the things that we've been able to enhance over the last decade. And I really am excited about what the future decades look like. In fact, the things that I know that we've already got engineering working on right now, I'm always impressed. I stand just dumbfounded at how much we can do with the team that we've got and with how much pressure we've got just to keep up with the existing customer demands. But when it comes to stands, yes, we've got engineered stands. We've got a whole bunch of things that you can end up incorporate. They've got jib cranes and lifting hoists to be able to service it. They've got conical discharges that we can put in polyurethane puck board to be able to make sure that they slide down and everything else. We can incorporate screw conveyors, belt conveyors. We've got all that application capability there. But if you ever are in a situation, and I know that my own sales team would be, angry by me saying this, we will help you it would be better for you to build out your stand locally. Yes, we sell equipment. We love to sell equipment. We can certainly do so. But stands is certainly not a sexy thing to manufacture as an OEM. And if given the cost or given the ability that you're wanting to locally go ahead and do so, we will be there to help you do that. And we will provide you the dimensions, the footprint of our vertical cutting dryer, and make sure that you can go ahead and integrate that as you wish. If you've got a special custom stand configuration that you want, by all means, we will also go ahead and modify or provide you some engineering services, and we can provide custom designs and build out that custom configuration also. So all that relative to the integration and everything else, don't hesitate. We can do that. I tried not to get down that topic because I don't want to make such a presentation seem like a sales pitch, but we can provide you all that support and everything else on that. Oh, and one item to the last question that popped up about the size of the motors. One thing to keep in mind that's very different with the classic series dryer or the classic dryers versus the modern direct dual drive dryers, which I completely omitted as a fringe benefit of the vertical cutting dryers, is that the classic dryers with the 75 horsepower motor, it has a large inrush. There is no inrush relative to the direct dual drive dryers. Because we're using VFDs that have a automatic sequencing in regards to how they operate and how the VFDs communicate, we mitigate predominantly all of that inrush. So it makes it much easier on your power source, and it also ends up making it a much better situation for your actual motors and the life of your power electronics equipment as a result of mitigating that inrush. So I forgot to note that in the last question that popped up. One more question, Ray.
No, we are done with questions right
excellent.
now. And we're good. We really appreciate everyone taking the time to join us today. We are 6 minutes over the hour mark, but thank you very much for hanging on. Excellent presentation. Thank you, Mr. Anderson, for your time. And we will be sending out follow-up emails where you can download this presentation from our website. Please keep an eye out for our next one coming up in the 3rd week of April. Thank you, everyone, and have a great day.
Thank you, Ray. Thank you, everybody.